Hello students, very good afternoon to all of you. So today I am going to explain PYQ of the chapter Principal Stresses and Strain pertaining to engineering services and GATE examinations. So frequently you will find a lot of objective questions and numerical type questions also in engineering services and GATE frequently. So this is a very important chapter. So today I am going to explain the last 10-year PYQs of the GATE and engineering services. So let's start. This is a question, engineering services 2017 questions. The state of stress at a point in a stress body is as shown in figure. Normal stress is in the x direction is 80. So normal stress is in the x direction is 80 MPa and in the y direction it is 40 MPa compressive. Radius of the Mohr circle for this state of stress will be how much? So let's draw a Mohr circle. This is my x-axis, this is y-axis. So tensile stresses I will plot on this side and compressive on this side. This is towards right side it is tensile stresses and on the left side it is compressive stresses. This we take positive and this negative. So here this is 80 MPa. Suppose this is 80. This is 80 MPa. So this is the origin. So this is 80 MPa. And on the y directions on this plane this is 40 MPa. Suppose this is 40. This is 40 MPa. Now this is 80 and this is 40. So total is 120. Total is 120. And no shear stress is acting on. So these 2 points, one is this. This is total. This is the diameter of the Mohr circle. And if I find a center of this, so it will be 60 from both sides. 60. So this is the center of the Mohr circle. This is center. So now I can draw a Mohr circle by putting here like this. So this is my Mohr circle. This is the Mohr circle and this is the center. So obviously this is the radius. This one is radius. This is radius. So radius is this. This 60 is the radius and this total 120 is the dia. So I can draw a Mohr circle by having a radius of 60. So the radius of the Mohr circle is 60 MPa. So this one is the right answer. Next question. For the state of stress shown in the figure, the maximum and minimum principal stresses. So I have to find the maximum and minimum principal stresses taking tensile positive and a compressive stress, how much it will be. So I have to find the principal stresses. So in this case, one thing is very clear, these shear stresses are always complementary. So they will act in couple. So if this is 25, here also it will be 25 MPa, and this is 25 MPa, and like this. So for drawing a Mohr circle, this is my x-axis, this is y-axis. This stress is 90. So 90, this is the origin. 90 will be here. This is 90. And on this plane, this is 30. So 30 is compressive. So it will be somewhere here. So this is 30. And here on this plane, shear stress is 25. So the tendency of the shear stress is rotate to in the anti-clockwise direction. So we considered this 25 MPa as positive. So this y-axis denotes the shear stresses. Negative will be on the upper side and positive will be downward. So this shear stresses, where 90 MPa is the tensile stresses, this 25 shear stresses will be here like this. So this is 25 MPa. And on this plane, where this 30 MPa is the compressive stresses, shear stress is 25. So tendency is to rotate it in clockwise direction, means negative. Negative means upward. So this will be 25. So I will get this. So this is the center of the Mohr circle, and this I will get the Mohr circle. So this is the Mohr circle. So obviously this is 90. 90 from here, this 90, and this is 30. So total from here to here it is 120. So it is 120 from here to here, it is 120. So this is the, so if this is 120 from here to, so it will be 60, and this is 60 also. This is 60 and this is 60. So principal stress means this one, where the shear stress is 0. This is principal stress. This is sigma 1 principal stress, and this one from the origin, this will be sigma 2. Minor principal stresses, this is major principal stresses. So this sigma 1 will be equal to how much? This is 60, this is 30. It means this is also 30. 30 plus 60. So this one is from the origin, this is 30. So my sigma 1 will be this 30 plus this one. This one is the radius of the Mohr circle, and this is also equal to this one. This is also the radius. This is the center. This is the radius. This radius is equal to this much. This is equal to this much. So this radius is equal to how much? This is right angle triangle. This is 25. This is 60. So this will be 60 square plus 25 square root. So I will get this one. So my major principal stress will be sigma 1 will be equal to this 30 plus 30 plus this radius is equal to this radius. So this plus this. So I will get and this root of this will be 35. So means no, root of this will be 65. The root of this 65 means it will be 95. So 95 MPa is the sigma 1, and sigma 2 is equal to, from the origin and this one, this is sigma 2, and this sigma 2 will be how much? This is the radius, this is the radius. Radius is this one, 60 square plus 25 square. This is the radius. So this radius from here to here, this is the radius, minus this 30. I will get a sigma 2, and this is 65 minus 30 is equal to 35, and since it is on the compressive side, so it means it is a minus. So this is minus 35. So this one is the right answer. The principal stresses at a point in a stressed material are this one, and this sigma 3. Volumetric strain is equal to how much? Volumetric strain means EV, change in volume upon original volume. This is volumetric strain, and this is equal to strain in the x direction, strain plus y direction plus strain in the z directions, and this will be equal to 1 upon E into sigma 1 plus sigma 2 plus sigma 3 into 1 minus 2 mu. This is Poisson ratio. The formula is this one. So if I put, this is basically Ex is equal to sigma 1 upon E minus sigma 2 upon Me minus sigma 3 upon M. This mu is equal to 1 upon M. So I can also say like 1 upon 2 upon M or mu. So Ey is equal to sigma 2 upon Y E minus sigma 3 upon Me minus sigma 1 upon Me, and Ez is equal to sigma 3 upon E minus sigma 1 upon Me minus sigma 2 upon Me. So by adding these, I will get this one, 1 minus 2 upon M, or I can say mu. 1 upon M is equal to mu. I can write both way, and this Poisson ratio is equal to 0.3. So if I put the value is, this is 210 kilonewton, means raised to the power 3 by multiply, I will get Newton per mm square. This is 1 upon E. Sigma 1 is equal to 200 plus sigma 2 and this is Newton per mm square into 1 minus 2 into 0.3. So this will be equal to 550 into 0.4. So this will be equal to 1.048 into 10 raised to the power minus 3. This is the right answer, and no option is here. So it means there is some mistake in the question itself. So right answer is this one. This is the next question. The state of stress at a point in an elastic material will yield stress of this much in simple tension, and Poisson ratio is this one as shown in the permissible value of this my maximum strain theory. What maximum strain theory is? What maximum strain theory says? maximum strain theory says that my principal strain, suppose this is sigma 1 and this is sigma 2. What it says, the maximum strain theory says that sigma 1 upon E minus sigma 2 upon ME, this strain in this direction will be this one. That should be equal to the strain in the simple yield test, simple tension or compression test. So this will be sigma 1 minus sigma 2 into mu R1 upon M is equal to Fy. So here sigma 1 is equal to how much? So this will be 1.4 sigma minus, this is compressive, so this will be minus 2 sigma into 1 upon M is the Poisson ratio into 0.3. That should be equal to this 200. This is the yield stress. So this will be 0.6 and plus 0.6 means 2 sigma is equal to 200. Sigma will be equal to 100. Means this is the right option. Next, you should consider the following statement. Which of the above statement are correct? So I have to find the correct options. In one, maximum shear stress is 1/2 of the normal stress in the case of uniaxial stress field. Yes. In case of uniaxial test, so this will be P by 2 and P by 2. So maximum shear stress is 1/2 of the normal stress. I can also draw the Mohr circle of this. So this is, suppose this is P. On the other hand, this is 0. So if I draw, this is the origin. On this plane, stress is 0. So I can draw a Mohr circle. And maximum shear stress is this one, this, and this will be half of this will be P by 2, P1 by 2 or P by 2. So maximum shear stress is half of the normal stress in case of uniaxial stress fields. So this is okay. In biaxial stress field acted upon by normal stresses accompanied by shear stresses, the maximum shear stress is any one of the normal stress. This is wrong. How can it be possible? Suppose this is P1, this is P2, this is Q, so this is, if I draw a Mohr circle of this, so it will be like this one. If this is tensile, then it will be plotted here. This is P2. So maximum shear stress is this one. This will be equal to, this is principal stress sigma 1, this is sigma 2. So this will be maximum stress tau max, Q max is equal to sigma 1 minus sigma 2. So it cannot be any one of the normal stresses. So this is wrong. And Mohr circle will be tangential to the vertical axis in case of uniaxial stress field. Yes, this is the uniaxial, and so Mohr circle in this case, since stress on this plane is 0, So Mohr circle will be this. So it is tangential to this y-axis. So this is tangential to the vertical axis, y-axis, in the case of uniaxial stress. So this is also okay. So 1 and 3 are the right options. It means this is the right option. If the strain on a piece of metal are this one and this, what is the maximum principal strain? If I draw a Mohr circle for strain, then this is x, this is y. So on the Ex is equal to minus, means this is minus will be here, it will be 120, and this is 30, minus 30, means this will also be plotted on the left side of the this axis, and this is 120. So in case of Mohr circle, this is 120 and this is positive. So positive means it will be plotted, this is positive, this is, and this will be half of this, this will be half of this. So half of this will be 60, this is 2, this is also 60. So this will be my Mohr circle. What is the maximum principal strain? Maximum principal strain will be where the shear stress is 0. This is my maximum principal strain. This is, and this one is, this is minor principal strain, maximum principal strain. So this will be this one. So it will be, this is 30, this is 120, means distance from here to here, this is 120 minus 30, this is 90, and this one, this is the center of the Mohr circle. So it will be 45, 45, this is 45, this is also 45. So this is 45, this is 60. So how much this will be? Radius, this will be 45 square plus 60 square root. This is the radius of the Mohr circle, and this radius is also equal to this radius. So this means from here to here, this is the radius of the Mohr circle. This will be 45 square plus 60 square root, and this side, this is radius. So this is, if this is a radius, then this is also equal to radius from here to here. So this is radius. So this will also be equal to radius of the Mohr circle, means this length is 45 square plus 60 square. So this is the radius. If I add this, and how much this will be equal to, and from here to here this is 30, or what I can say, this is, this distance will be, is the center. So this is 30, this is 120, this is 30. So this will be 120 plus 30 divided by 2. Average of this distance will be 120 plus this is 150 by 2, means this is 75. So from here to here this is 75. So this is 75 plus this is 30, this is 120, and this is the average of this. So this is half of this. So this 75 plus radius of the Mohr circle. This is 45 square plus 60 square. So this will be equal to So root of this will be 75. Means 75 plus 75 is the 150. So 150 is the measure principal strain. So this is the right option. The state of stress at a point is given by sigma x is equal to this, sigma y is equal to 81 and tau xy is equal to. So this is like this. Sigma x is equal to 80. This is 100 and this is 60. So all are positive means like this. So let us draw Mohr circle. This is 80 origin. So this is 80 and stress here is 60. So this is positive. Positive means like this. So this is 60 and this is 100. This is 100 MPa. This is equal to sigma y. This 80 is equal to sigma x is equal to 80. So this also 60. So this is my Mohr circle. So what he want to know that what is the value of the maximum shear stress. Maximum shear stress. So maximum shear stress means so this one is measure principal stress sigma 1 and this will be sigma 2. This is 100, this is 80. So it means this distance is 90. This is the 90. So measure principal stress will be this 90. Sigma 1 is equal to 90. This is average of this is 80. This is 100. So this is the average. So average of 100 plus 80 is equal to 90. So from the center of this circle, this distance is 90. This 90 plus this is the radius of the Mohr circle. This radius is equal to this radius and this radius is equal to how much? This is equal to this side square plus this side square. This is equal to this is 100, this is 100, this is 80. So it means this is 20 from here to here. So this is 10. This is also equal to 10. So this is 10 and this is 60. So this side will be equal to 10 square plus 60 squares root. So this I will get this radius. This radius is equal to this one. If I add this plus this 90, I will get measure principal stress. Means this will be equal to 10 square plus 60 square. Means this will be the root of 37 will be this I will get 6.083 means this will be 60.8 plus 90. So 150.8 is the measure principal stress. It means this is the maximum shear stress. So I think it is a maximum principal stress. Some mistake is there here. So this is the right option. Maximum shear stress will be obviously equal to the radius of this Mohr circle, which is equal to this one. So this is the maximum principal stress. Some mistake is there. Principal stress is at a point in an elastic materials are this, like this. And this is a three-dimensional. So in this direction it is sigma 3 is equal to, this is minus 0.5 sigma. This is compressive. So elastic limit in the tension is, elastic limit in simple uniaxial tensile stress, this is 210 MPa and mu is equal to this. So the value of sigma at failure when computed by maximum principal strain theory. What maximum principal strain theory says? So maximum strain theory will be equal to, my maximum strain will be obviously in these directions. So it will be sigma 1 upon E minus sigma 2 upon ME minus sigma 3 upon ME. That should be equal to the Fy upon simple uniaxial tensile stress divided by E. So E and E, this will cancel each other. So sigma 1 is equal to 1.5 sigma minus 1 upon M. This is mu. And sigma 2 is equal to sigma minus sigma 3. Sigma 3 is compressive. So it will be minus 0.5 sigma into mu. This is equal to 210. This is the elastic limit. So it will be 1.5 minus 0.3 plus, this will be 0.15 sigma is equal to 210. So this will be 1.2 plus 0.5 means 1.35. So 1.35 sigma is equal to 210. So sigma will be equal to 210 upon 1.35. So 210 divided by 1.35, this will be, I will get this one. So this is the right option. Normal stresses on two mutually perpendicular planes are this one, this one, this. If the maximum shear stress is this, the shear stress on these planes will be this one. So this is 140, this is 70. If the maximum shear stress is this one, then shear stress on these planes will be, suppose this is Q. So this is Q. So let's draw Mohr circle. This is 140. And this is 70. So on this, the Q is positive, means this is Q, and this is also equal to Q. So this is the Mohr circle. So this is 140, this is 140, this is 70. 140 minus 70 is equal to 70. So this means this is 70. So this is the center. So it will be 35, 35 each. So this is 35 and this is Q. What he says that if the maximum shear stress is 45, what is the maximum shear stress? Maximum shear stress is this one. This is Q max, maximum shear stress. And this maximum shear stress is nothing but the radius of the Mohr circle. This is radius of the Mohr circle. So this radius of the Mohr circle, Q max, this is equal to this much, and this radius is equal to how much? This will be 35 square plus Q square root. This is the radius, and this radius is the equal to this radius, which is equal to maximum shear stress, and this is equal to how much? This is 45. So squaring both sides, I will get 45 square. So Q square is equal to 45 square minus 35 square. It means Q is equal to 45 plus 35, A plus B into A minus B. So this is 80 and this is 10. So, and Q will be equal to root of this. It means this is 800, this is 10 into, so 20 into root 2 means 20 into 1.414. So I will get 28.3. So this is the right option. The normal stress is on two mutually perpendicular planes. On this plane it is 120 and this is 60. Both are tensile, means if the shear stress across these planes is 30 amperes. This is 30, this is 30 and this is 30. So this is the stress system. I have to know the maximum principal stresses. So principal stresses is equal to, if I draw a Mohr circle, then it will be, this is the origin, this is 120 and shear stress is 30. This is, try to rotate it counterclockwise, means positive. So this is 30 and this one is 60 and shear stress is this is 30. If I join together, I will get, this is the center of the Mohr circle. So principal stress is equal to, this is major principal stress sigma 1 and this is sigma 2, where shear stress is equal to 0. This is sigma 1, this is sigma 2. Sigma 1 is equal to how much? This is 120, this is 60. So obviously this will be average of these two. So this will be 90. So this 90 plus this is the radius of the Mohr circle. This radius is equal to obviously this one. And this 90 plus, so sigma 1 is equal to, this is 90 plus this one. This is the radius of the Mohr circle, and this radius is equal to this one, and this is equal to this 30 square plus this side square. Since this is 120 and this is 60, means this total is 60. So this is 30, 30. This is 30 and this is 30. So it means this is 120 minus total is 60. Difference of 120 and 60. So 60, this is half of this 30, 30. So this is 30, this is also equal to 30. It means this is equal to 30 square plus 30 square means, if I take this 30 square common, then it will be, so 90 plus 30 into 1.414. So it will be 42 something. So 90 plus 42 means 132, and this is tensile. So B and D both have 132 MPa in them. So I have to check this also. So this minus sigma 2 will be equal to how much? This is 90 minus, this is 90 minus this one. This is the radius of the Mohr circle, and radius of the Mohr circle is how much? This is 30 square plus 30 square, this one. Means this is 90 minus, this is 42 something. So it will be 48. So 132 and 48, and both are tensile. So this is the right option. Again, at a point in a metal, these stresses acting on two planes at right angle to each other are this one. Maximum shear stress on the element will be this is 200. Mistake is there. So this is 120 and this is 200. This is 200 and shear stress is minus. So minus means it will be plotted upward. So this is 80 and here it will be 80. So this is my Mohr circle. So maximum shear stress means this is my maximum shear stress is Q max, and this maximum shear stress, this is nothing but the radius of the Mohr circles. So this radius is equal to this radius. So Q max is equal to this, Q max is equal to this one. This is the radius, and this radius is equal to this side square plus this side square. How much this side will be? This is 200, this is 120, means 200 minus 120, this is 80. and this is half of this. So this is 40 and this is 40. This is 40 and this is 80, means this side is equal to 40 square plus 80 square. So it will be I think yes, some mistake is there. This is some mistake is there. This is minus 200, I think. So it will be like this. This is 120. And shear stress is minus, means it will be plotted. This is 80. And this is minus 200. Minus means it will be plotted on this side. So total it will be, my Mohr circle will be like this one. So this and shear stress is, oh, this is, I can say this is 200 and this is 120. So total is 320. 320 means 320 from here to here. So it means this is 80 and this is 80. So this will be the center of the Mohr circle. So maximum shear stress will be equal to the radius of the Mohr circle. So radius of the Mohr circle means this one. So this is 80. So total is from here to here, it is 200 plus 120 means 320. So 320 means this is 320 from here to here. It is from origin, from the center of this Mohr circle, it will be 160, 160. So this is 160, this is 80. So this radius is equal to 160 square plus 80 square root. And this radius is equal to this radius. And this is equal to Q max, maximum shear stress. So this Q max is equal to radius of the Mohr circle, which is equal to this one. So this will be so this will be 80 root 5. 80 root 5 means root of 5 is equal to how much? It is 2.24 something. So it will be so it is 179.20 something. So this one is the right options. This one is the right option. The principal stresses in the wall of a container are like this. This is 40 and this is 80. Normal, this normal of this plane making an angle of 30 with the direction of the maximum principal stress. This is direction of maximum principal stresses. So this is making 30° with this one. I have to find the resultant stresses. So all the derivation which I have made this after taking this theta, which is with the vertical. So theta is here, theta is with the verticals. So if this is 30, means normal of this is this one and normal of this is equal to this one. So this theta is equal to 30. So this is the plane. I have to find the resultant stresses, how much it will be. This is the Mohr circle. So this is 80 and this is 40. And shear stress is 0. No, shear stress is 0. It means this is my Mohr circle. Its dia is 80 minus 40 means 40. This is the dia and radius is this is 20. So on 30°. So theta is 30 means this will be 2 times of theta. So 2 theta means 60°. So this point, this will give normal stress and this will give tangential stress. Means normal stress, this will be equal to how much? So from here to here it is average of this. This is 40, this is 80, means it is 60. So this 60 plus how much this will be? This is the horizontal projection of this radius. This is normal stress Pn is equal to 60 plus, so the radius is 20 obviously, 40. So 20 cos 2 theta means cos 60°. This is 60° and this will be equal to, this is 70, means this is 70 and this normal tangential stress will be 20 of sine of this angle. So 20 sine 60 means this is 0.866. So this will be equal to, so this is 17.32. So this is 17.32. So resultant stress, this will be the resultance. So this will be equal to P normal square plus P tangent square. So resultant stress is equal to P normal square plus P tangential square root of, means it will be 70 square plus this tangential square means 17.3 square and whole of this will give this resultant stress and this will be equal to $70. So this will be, I will get 72. So this is the right answer. A bolt under an axial thrust of 9.6 kilonewton together with a transverse force of 4.8. So there is an axial thrust and then there is a transverse force. Transverse force means shear force. So this is the shear force and this is the axial. Suppose this is my bolt. So this is axial thrust means 9.6 kilonewton and transverse force means like this. So this is 4.8 kilonewton. A factor of safety is 3. Yield strength of the bolt material is 270 and Poisson ratio is 0.3. Its diameter as per maximum principal stress theory. What maximum principal stress theory says? Maximum principal stress theory says that when maximum principal stress sigma 1 becomes equal to Fy, yield stress, then the material will fail. It means I have to find the maximum principal stress. So here my normal stress is equal to how much? This is 9.6 kilonewton. This is in Newton divided by area of the bolt. Area of the bolt is pi by 4 d square. And shear stress Q is equal to this transverse force upon area of the bolt. So this is P and this is Q. So principal stress will be equal to, this is P and this is Q. On the other plane, like this is the case like this. This is P, this is P, this is Q and this is Q. No stress, normal stress on this plane. So it is 0 here. So this will be Q. My sigma 1 will be equal to, this will be obviously equal to half of this P by 2. This P by 2 plus radius of this one. P by 2 plus radius of this will be, this is also P by 2 plus Q square. This will give radius. So major principal stress sigma 1 is equal to P by 2 plus root of P by 2 plus Q square. So P by 2 is equal to how much? This is this one. Means half of this. So 1 by 2 into this one. This is P by 2 plus root of P by 2 plus Q square. P by 2 is this one. Square of this plus Q square. So Q in this case is, this is Q. So this I will get, this is the principal stress and this principal stress becomes equal to the yield strength, equal to yield strength. So yield strength, this is the yield strength and this yield strength divided by the factor of safety, I will get working stress 270 upon 3 is equal to 90. So this will become my equations. So after solving this equation, 90 is equal to this plus this root. So from this equation I can get diameter of the bolt, and this diameter of the bolt will comes out is 12.80 mm, means 13 mm. Calculation part you people can do. So it means this is the right option. In a material, the principal stresses are 60, 48 and this one. So value of E is equal to this one and Poisson ratio is equal to this. Total strain energy per unit volume will be equal to how much? So total strain energy in this case will be equal to so principal stresses are 3, 60, 48 and minus 36. When the value of E is equal to this, to total strain energy stored per unit volume, strain energy stored per unit volume is F square upon 2E. So it means this will be equal to one upon 2E into sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1 upon m. This will become is equal to this one. Strain energy in case of uniaxial direct tensile test. So this will be equal to, this is not required. So simply I have to find the total strain energy per unit volume. So this is become equal to this one. So 1 upon 2 into E is equal to how much? Giganewton per meter square. So it will comes out to this Newton per mm square, and inside it will be sigma 1 square plus sigma 2 square means 60 square plus 48 square plus 36 square minus 2 into 1 upon m is mu is equal to 0.3, and sigma 1 sigma 2 means 60 into 48 plus sigma 2 sigma 3 plus sigma 3 sigma 1. So if I solve these equations, so I will get 19.5 kilonewton meter per cubic meter. So this answer I will get after calculating this equation. At a point in a two-dimensional stress system, the normal stresses on two mutually perpendicular planes are sigma x, sigma y, and shear stress is tau xy. One of the principal stress will become 0 when the value of the shear stress tau xy is equal to how much? So one of the principal stresses will become 0, means formula for maximum principal stress is equal to sigma xx minus sigma yy by 2 square plus q square. This is the formula, means this is sigma xx, this is sigma yy, this is tau xy, this is tau xy, and this will be equal to average of this sigma x plus sigma y by 2 plus this radius. This is sigma xx minus sigma yy by 2 square plus tau xy square. This is the radius. This I will get this one. So this will be plus minus, means what he says that one of the major principal stress will become 0 when the value of the shear stress is equal to 0. So obviously this, if I take minus here, then my shear stress will become, when the value of the shear stress is this one. So one of the principal stress means, suppose sigma 2 is equal to sigma tau xx plus sigma yy by 2 minus this one. When this becomes equal to 0, means this is equal to this, means whole square of this will be so this will be equal to whole square of this will be equal to so this square of this this will cancel each other. I will get this will be minus tau sigma x sigma yy plus tau xy square. So this is 1 by 2, this is 1 by 2. So it will be sigma xx into sigma yy is equal to tau x square root. So it means tau xy is equal to root of this one. So plus minus root of tau sigma xx into sigma y, means this is the right answer. An ISHB 300 with plastic section modulus ZP is equal to 921.68 into 10 raised to power 3. The flange width is 250 mm. Yield stress is 250. Embedded in a pocket base to develop its strength with MEM25 concrete in design of beam column. The required depth will be, I think this section, this belongs to steel limit state design of steel structures. So mistakenly this question has put here, but anyhow we can solve this. The formula is 0.164 FCK BD square is equal to plastic moment of resistance MP. This is equal to Fy into section modulus ZP. So with this formula I can get depth. So depth will be this one 425. So let us take this question during our steel lecture. Normal stresses of 126 and this compressor are acting at a point in an elastic material at right angle to each other. If the maximum principal stress is limited to 146, the shear stress that may be allowed at that point in the same plane is this. So this is 126, and this is 94, means it will be plotted here on the compressive side. This is 94, and the maximum principal stresses is limited to this one. Suppose this is Q, this is Q, so this is my Mohr circle. So this is 120 and this is 126 and 94, means this total distance from here to here, this is equal to 126 plus 94, means 220. So this is 220. So this is 220, and this is the center of the Mohr circle. This is the origin, means this is half of this. So this is 110. This is also equal to 110. This is Q. So what he says, the maximum principal stress means this one is sigma 1 is equal to 146. This is 146, and this maximum principal stress 146 from here to here means how much this will be. So obviously this will be equal to means this distance is equal to, this is 110 from center of the Mohr circle to this point, this is 110, and from the origin it is 94. So 110 94 means this distance will be equal to 110 minus this 94. 110 minus 94 means this will be 16. So my maximum principal stress, this will be this 16. This is 16. So this is 16. So this from the origin, this is 16 plus this distance, and this distance is equal to this distance. This is the radius of the Mohr circle. This will come equal to this. So this is the radius of the Mohr circle. This is the radius, and this. So this radius plus this 16, and radius is equal to 110 square plus Q square. This I will get radius, and this radius is equal to this one. So this, when I add plus 16, I will get measure principal stress, which is equal to 146. Means this will be equal to 146 minus 16 is equal to 130. Squaring both sides, I will get this square plus this square is equal to 130 square. Means Q square is equal to 130 square minus 110 square, and this will be equal to 130 plus 110 into 130 minus 110. So this will be 240 into 20. So this is 4800. So Q is equal to root of this. This will be equal to 1600 into 3. The root of 1600 is equal to 40 into root of 3, and this is 0.132, means this is 69 point something, means this one is the right option. A plane element in a body is subjected to a tensile stress of this and shear stress of this one. What is the normal stress on a plane inclined at 15 degree with the tensile stress? Means this is the case. This is 100 MPa and this one is 25, and normal stress on this plane is 0. So I have to find the stress on this plane, which is making an angle of 15 degree with the this is so this is the plane which is making an angle of 15 degree with the tensile stress. So this is making 15 degree with the tensile stress, means if this is 15, then obviously it will be 90 minus 15 means 75 degree. So if this is 75, means this angle is 75 degree. So theta here is equal to 75, and this will be, since the rotation is clockwise, means theta is minus 75 degree. So theta is minus 75 degree. Usually I take like this. So when theta it rotates in the anti-clockwise direction, this is positive, and when the rotation is theta is clockwise, it is negative. So theta is minus 75 degree. So normal stress, the formula for normal stress is equal to I can find it from the Mohr circle also. This is 100, this is 25, and this is 25, this is 0. So this is my Mohr circle. This plane represents this one. So I have to rotate by 150 degree. 150 degree means this direction, this is 2 times of theta, means minus 150 degree. So this angle will be 150 degree, and this is 150 degree from here to here, and this angle I can find, this will be equal to, this is 50, this is 100. So this angle is equal to 10 inverse 25 upon 50. So I will get this angle. And this angle will be equal to Mm. This is 6.56 degree. So, and this total, this is 150. So 150 plus 26 means 176.56, means this angle is equal to 180 minus this. So 180 minus this will be equal to this angle will be 3.44 degree. So normal stress means this is the horizontal projections. So from here to here, this will be my normal stress, and this will be equal to normal stress here will be equal to this is 100, means it is 50, this is 50, and this is the radius. So radius is equal to, this radius is equal to 50 square plus 25 square. With this I will get this radius. So this is the radius. So this radius into cos of this angle, which is cos 3.44 degree, I will get this one. And radius is equal to, this is equal to 55.9, and this angle will be cos of this angle, means 55.9 into cos 3.44 degree. So with this I will get, and this is 50, means this will be on the this side. So means 50 minus 55.9 into cos of this angle, I will get this one. So this is the right option. Otherwise we can simply find this by putting in the formula. The formula is P normal is equal to P1 plus P2 by 2 plus P1 minus P2 by 2 cos of 2 theta plus tau xy, tau into sine of 2 theta. So here P1 is equal to 100 plus P2 is equal to 0 plus P1 minus this by 2 into cos of 2 theta. Cos 2 theta means theta is 75 degree. So cos 2 theta means minus 150 degree, and plus tau xy, this is 25 into sine of 150 degree. So this will be 50 plus 50 into cos of this, cos minus theta means so after solving this I will get this one. So this way we can easily calculate it. The stress is at a point of a machine component are 150 and both tensile. So this is like this. This is 150. This is 50. What is the intensity of normal stress on a plane inclined at 30 degree with the axis of the measure? Like this is my plane. So this is the axis of the measure principle, measure tensile stress. So this is making 30 degree. With this, it means this is the my plane. So if this is 30, then obviously if this is 30, then this will be 30. So it will be 60. This is 30, this is 60. It means theta here is equal to minus 60 degree. So what is the intensity of a normal stress on a plane inclined at an angle of 30 degree? Means P normal is equal to P1 plus P2 by 2 plus P1 minus P2 by 2 cos 2 theta plus tau या Q we can say sin 2 theta. So P1 is equal to 150 plus 50 by 2 plus 150 minus 50 by 2 cos 2 theta means cos minus 120 degree. Since the rotation is clockwise, so theta is minus 60, 2 theta means minus 120 plus Q. So shear stress in this case is 0. So this will be, this is 200 by 2 means 100, and this will be 50 into cos minus 120 degree means cos minus theta means minus cos theta. It will be 50 into cos 120. Cos 120 means 90 plus 30. So it will be sin 30. So it will be sin 30 and means 1 by 2 25. So 100 minus 25 means 75. So this is the right option. A flat bar of 10 mm thick and 100 mm wide. So this is like this. So this is my flat bar. Is subjected to a pull of 100 kilonewton. One side of the bar is polished and the lines are ruled on it to form a square of 50 mm side, one diagonal of the square being along the middle line of the polished section. This is like this. So like this. So its diagonal is along the axis, tensile axis, middle line of the polished side. So this is 50 mm, 50 mm, 50 mm and 50 mm. What is the change in the side? So during tensile stresses, strain will be produced, tensile strain, and its dimension will change. So it will be like this. Suppose I draw this one like this. This is 50, 50, 50 and 50. So this is the diagonal. So after the tensile stresses, it will deform like this one. Means its length will increase in this way and its width will decrease. So now my stress is equal to load upon area. Stress is equal to load is 100 kilonewton, means this upon area is this one. So this stress I will get 100 Newton per mm square. This is a tensile stress. And strain in this direction will be equal to how much? Strain will be equal to strain in this direction. Suppose it is E1 is equal to this stress upon E, Young modulus of elasticity, and this. So this will be the strain in this direction. Well, this is E1 or E2, and E2 will be in this direction. There will be a decrease. So decrease means minus, and due to Poisson effect, this strain in this will be equal to strain. This will be equal to 5 into 10 raised to the power 4. So this multiplied by the Poisson ratio, which is 0.3, I will get this one. So this will minus 1.5 into 10 raised to the power minus 5. So this is the strain here. So one diagonal of the square belongs. So I have to find this one. This angle is equal to basically 45 degree. So along 45 degree I have to find the strain. So formula for strain is equal to E theta is equal to, it's very simple. So by Mohr circle also I can, this is 5 and this one is 1 point, this is 1.5 into 10 raised to power 4, and shear strain is 0. So this will be my Mohr circle, and theta in this case is 45 degree, and this is the plane which represent the this one, and 45 degree means 2 theta means 90, means this will be equal to 2 theta is equal to 90 degree. It means this is the center of the Mohr circle, and this is the origin. So it's like this. So this one will give my strain. So strain here will be equal to this much. So when theta is 45 degree means, so this, the horizontal projection of this point from the origin will give the normal strain here. So my E theta means E 45 degree will be equal to this much, and this much will be equal to how much? This is 5 and this is 1.5 on the negative side, so total is 6.5, and this is half of this, so half of this will be 3.25. So this is 3.25 from the center of the Mohr circle, and from the origin it is 1.5. It means this one is equal to 3.25 minus 1.5. So 3.25 minus 1.5, this will be equal to 1.75. Means 1.75, this is the strain here. So 1.75 into 10 raised to the power minus 4, this will be the strain here. So it means strain when theta is 45 degree, so strain here is this one. And this strain is nothing but change in length upon original length. So change in length upon original length means so initially this one, this is 50, this is 50. It means this is also 50. I can say this is 50, this is 50. So this length is 50 root 2. So this is 50 root 2 from here to here. So this 50 root 2 multiplied by this 50 root 2 multiplied by the strain, I will get change in the length. So this will be this 50 root 2 means diagonal. Change in the sides. Oh, oh, change in the side means this one. So this is, it will not be there. So I will get, so this 87.5 into this, I will get this one. So this is the right option. Maximum principal strain theory of the elastic failure is also known as, maximum principal strain theory is also known as which one? Guest theory, Rankine theory, Hake theory, or Saint Venant theory. So there are 5 theories: R, S, G, H, M, RSGHM, RSGHM. These are the 5 theory. R means Rankine, this is Saint Venant, this is Guest theory, this is A theory, and this is my Henke theory. This is for principal stress, this is for principal strain, this is for shear stress, maximum shear stress, this is strain energy, and this is shear strain energy, shear strain energy. So these are the 5 theories: Rankine, Saint Venant, Guest theory, RSG, HM. Principal stress, principal strain, shear stress, strain energy, shear strain energy. He wants to know about the maximum principal. This is maximum principal strain energy, means this means. So Saint Venant, this is the right option. Which one of the following is the limitation of maximum strain energy theory? Maximum strain energy theory, the theory does not apply to ductile materials. It can only be applicable for the material under the hydrostatic pressure. It cannot be applied for material under the hydrostatic pressure. The theory does not give accurate results in case of a torsion test. So this is wrong. This can be applied to the ductile materials. It can be a yes. It cannot be applied for material under the hydrostatics. The theory does not give accurate result for the torsion test. So this is the right option. So in case of ductile material, maximum strain energy. So torsion means my failure occurs at 90 degree, theta is equal to 90, whereas this theta will give 45 degree. So this is the limitation of this one. Two of the principal stresses at a point of 131. What is the safe range of the third principal stress in the point by using maximum shear stress theory? What maximum shear stress theory says? Maximum shear stress theory says sigma 1 minus sigma 2 by 2. This is the maximum shear stress, and in case of direct uniaxial test it will be Fy upon 2, means so using maximum shear stress theory, this is the maximum shear stress theory. What is the take the failure stress in tension is, this is 210 mm square. So it means I have to know the range. It's 130, 90. So 130, 90, and third is, suppose this is sigma 3. So if I take this one, then it will be equal to this range will be equal to safe range of the third principal stress theory. So it means this 130 minus sigma 3 by 2 is equal to 210 by 2. So this sigma 3 will becomes equal to minus 80. If I take this and this, 90 minus sigma 3 by 2 is equal to 210 by 2. Then sigma 3 will becomes This will be 90 minus 210, 90 minus sigma 3. So it will be, and then this will sigma 3 minus 132 by 2 is equal to 210 by 2. So maximum shear stress theory. Is minus 80, and then it will be, so there are three stresses. Two of the principal stress, one is 130, another is 90. And what is the safe range of the third principal stress at the point by using maximum shear stress theory? Suppose this is sigma 3. It means if I take this and this, then 130 minus sigma 3 by 2, that will be equal to 210 by 2. And sigma 3 is equal to 130 minus 210, means minus 80. So this minus 80 is one of them, and another is, if I take maximum of this, then if I take this and this, suppose if I say this is greater than this, then so this will be sigma 3 is equal to 210 plus 90 is equal to 300. So the value of the sigma 3 is minus 80 and 300. So this will be the right option. Normal stress across the principal stress is known as, on the principal plane, my stress is principal stresses. So this is the right option. If the principal stresses at a point in an elastic material is 2F tensile, this and this, what is the value of F at failure using maximum principal stress theory? What maximum principal stress theory is? Out there, one is 2F tensile, another is 1.5F, and this is F compressive. So out of this, the maximum is 2F. This maximum stress should be equal to the yield stress in simple tensile stress. So this is 210. So this will become equal to 210. Then F will become 210 by 2 means 1.105. So this is the right answer. Consider the following statement related to maximum shear stress theory, means guessed theory. This theory is well justified for ductile material. So I have to find which of the following statement is or not correct. So not correct means this is correct. It gives accurate results. It gives accurate result for the state of stress of pure shear in which the maximum amount of shear is developed. It gives accurate results for the state of stress of pure shear in which result of this theory differs from the experimental result from this. This is also right. So wrong means this one. So it means this B is the right options. It gives accurate result for the state of stress of pure shear in which maximum amount of shear is developed. So this is in case of pure shear. So this is Q. This is Q. So it will be like this. It will be tensile here, Q, and on this side it will be compressive. What this shear stress theory says, the sigma 1 minus sigma 2 by 2 would be equal to maximum shear in case of uniaxial test. So in this case, this is Q minus this is minus Q divided by 2 is equal to Fy by 2. So it will be 2Q upon 2 is equal to Fy by 2, means Q is equal to Fy by 2. So it doesn't give the accurate results. The value of the failure is somewhere like 0.557 Fy. It is not 0.Fy, means this is wrong. This test is on two perpendicular planes through and a point are 60, 40 and 30. What is the absolute normal stress on a plane at 60 degrees to that of the tensile? Means it is like this. So this is a plane. 60 degree to that of the tensile stress. So this angle is 60 degree. If this is 60, means this is also 60. So this one is equal to 30. And since the rotation is clockwise, so theta means minus 30 degree. So if I put in the formula, so this will be equal to P normal is equal to P1 cos square theta plus P2 sin square theta, and P1 plus P2 by 2 plus P1 minus P2 by 2 cos 2 theta plus Q into sin 2 theta. So simply putting in the formula, I will get this one. So this is 60 P1 and this is 40, means this will be this divided by 2 plus this minus this into cos 2 theta, means cos 2 theta means this is cos minus 60 degree plus shear stress. Shear stress is 30. So this is 30. This is 30 into sine 60 degree. So this will be 10 and this will be 50. This will be cos minus theta means minus cos theta, and cos 60 means 0.866 1 by 2, and sin 60 is equal to sin minus theta is equal to this is also I think 0.866. So this will be 10 minus 25 and yes, so absolute so oh 60 degree means anyway you get answer is this one will be the answer. Statement: any orthogonal set of axes are 180 degree to one another on Mohr circle. Any orthogonal set of axes are 180 degree to one another on the Mohr circle. Suppose this is P1, P2. So if I draw the Mohr circle, it will be like this. This is P1, this is P2. So this will represent this one, and this plane from center to this CP1 will be represented by this plane, and this CP2 will represent this plane. So these both the planes are 180 degree in the Mohr circle, means this is okay. The distance between these axes is half the diameter of the circle. So distance between these axes, so this to this distance is basically this is the dia of the circle, not half of the dia, means this is wrong, means statement 1 is true and statement 2 is false. So it means this is the right option. Which one of the following statement is not a proper property of the curves? Both the system of the curve cross each other at 45 degree. Each system crosses the neutral axis of 45 degree. At any point of the curve, the tangent and normal give the direction of the two principal stresses. The intensity of the stress along each curve is greatest when it is parallel to the length of the beam and diminishing along the curve to 0 when it is cut the face. So basically these are the envelope of principal stresses. This is my neutral axis. So this will be compressive and this is tensile. So it will be like this. So they crosses each other. These are orthogonal. So 90 degree. So this is wrong, means this is not correct. So it means this is the right answer. And the angle with the neutral axis is 45 degree, means this is okay. This is also okay. At any point of a curve, give the tangent and normal we give the direction of the two principal stresses, and the intensity is maximum when it is parallel to the length, and it is 0 when it is cut the face at right angles. So all are okay, but this is not okay, means this is the right options. Not a property means this is the right option. Consider the following statement regarding the two-dimensional stress formulation. If a plane stresses are identical for any given geometry loading, the in-plane stresses are different for plane strain or plane stress. The linear viscoelastic stress fields are different for constant load and change with time. Which of the above statement is are correct? The in-plane stresses are different for plane strain. So this is wrong. Linear viscoelastic stress fields are different for constant load and change with time. This is also wrong. So this is the right options. These radius of the Mohr circle as we described, this is equal to this one, sigma x minus sigma 2 by 2 square plus tau square. So this B is the right option. Which one of the following statement is not correct regarding theories of failures? The cause of failure depends on the properties of the materials. Is not correct. This is correct. In the case of brittle material, the maximum principal stress theory should be used. This is also correct. For ductile material, the maximum shear stress theory gives a good approximation. This is also correct. The cause of failure is not dependent on the stress system. How can it be possible? Always it depends on the stress system. Means this is not correct. So not correct means this one is the right option. The principal stresses at a point in an elastic material are 2F tensile, F tensile. If the elastic limit in simple tension, then according to measure maximum principal stress theory, the value of sigma is equal to what maximum principal stress theory is? This sigma 1 when this becomes equal to Fy, or sigma 2 bar becomes equal to Fy. So in this case, this is 2 sigma becomes equal to 200. So sigma is equal to 100. And when this becomes 2 tens, so I will consider this one. So sigma is equal to 100. B is the correct option. In the case of simple tension or compression, the maximum shear stress is equal to, in case of simple tension or compression like this, so it will always be when theta is equal to 45 degree on this plane, my shear stress is equal to half of this. This is normal stress is also equal to half of this, and shear stress is also equal to half of this. Otherwise, I can also find it from the Mohr circle. This is 0, this is P, and this is P by 2. This is also equal to P by 2. So this is tangential stress means shear stress. So this is equal to P by 2. And this becomes when theta is equal to 45 means this is 2 theta 90. So when the applied stress the applied stress is equal to half of the applied stress and act on a plane at 45 degree. So this one is the right option. For a general two-dimensional stress station, the maximum principal stress theory, the maximum principal stress formula is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 by square plus this one. So this one is the correct option. On a principal plane, the value of shear stress is always 0. Whenever there is a principal plane, my shear stress, so suppose this is P1, this is Q, this is P2, this is Q. So this is my major principal stress, this is minor principal stress. So on both the points here, my shear stress, this ordinate of this shear stress is 0. So whenever there is a principal plane, my shear stress is 0. So this C is the right option. A rectangular block is subjected to two perpendicular stresses 10 MPa Newton. This is my like this. This is 10 MPa and this is 10 MPa compressive. What are the stresses on planes? Inclined at 45 degree. Means this theta is 45 degree. If I draw a Mohr circle, then it will be, this is the origin, this is tensile 10, this is compressive 10. So this 10 becomes equal to this 10. So shear stress is 0. If I draw a Mohr circle, then it will be like this. So when theta is 45 degree, means this plane is represented by this one, this plane is represented by this one. So this theta 45 degree means anticlockwise 2 theta rotations. So anticlockwise 2 theta from here is 90 degree. Means at this point, you want to know the stresses on planes inclined at 45 degree with the horizontal plane. With the horizontal means vertical also it will be 45 degree. So on this plane, my normal stress is 0 since it is on the origin. So normal stress is 0 and shear stress is equal to how much? This is 10. So this will also be equal to 10. So this is on the upper side means negative. This is negative side and this is positive side. So counterclockwise rotation means this is the right option. The angle made by the resultant stress with the normal of the oblique plane is known as angle of obliquity and is expressed by this one. Shear stress upon normal stress suppose this is the case, and if I draw a Mohr circle for this, then it will be like this. On this plane, this is P and it is 0 here. Shear stress is also equal to 0. So this will be my Mohr circle. So for any angle, suppose if I want to know the stresses on this plane which is making a theta, so it will be 2 theta So this will give the normal stress, and this will give shear stress or tangential stress. And this, if I draw a line, this will give the resultant stress PR. Resultant stress will be equal to P normal square plus PT square. This is the right angle triangle, and this angle is the angle of obliquity 5. This angle of obliquity tan phi is equal to this side upon this side. This is shear stress, means shear stress upon normal stress. So tan phi is equal to shear stress upon normal stress, means this one is the right option. At a point in an elastic material, a direct tensile stress of this and direct compressive stress of this are applied on planes at right angle to each other. If the maximum principal stress in the material is limited to 75 Newton per mm square, then what is the value of the maximum shear stress? This will the center of the Mohr circle, and shear stress means so this is, so it is Q. This is my Mohr circle. Though this is 120, means this is 60, and this is also equal to 60. Means this is 50, this is 60. So this one is 10. This is 10. So major principal stress will be from here to here. This is sigma 1. Sigma 1 is equal to this 10 plus this one. This is equal to the radius of the circle. This is equal to the radius of the, this radius, this is also equal to radius. And this is equal to this 60 square plus Q square root. This will give the major principal stress, which is equal to 75 in this case. It means 60 square plus Q square root is equal to 75 minus 10 is 65. Square in both sides, I will get 60 square plus Q square is equal to 65 square. So Q square is equal to 65 square minus 60 square. So Q will be equal to this Q square is equal to 65 square minus, this is 65 plus 60, into 65 minus 60. This will be 125 into 125 means into 5. This is 625. So Q will be root of this. Root of this will be 25. So my value of the Q is 25. So this is 25. It means this radius, this is the radius, and this radius is equal to 60 square plus 25 square root, and this radius is equal to, this is also equal to radius, this is Q max. So Q max is equal to radius of the circle. Radius of the circle is 60 square plus 25 square, and this will be equal to, I will get, this is 65 Newton per mm square. Means this one is the right option. A material has strength in tensile. A material has strength in tension, compression and shear as 30 Newton, 90, 25 Newton respectively. If a specimen of diameter 25 mm is tested in compression, then identify the failure load and failure plane. Means failure load and failure plane. So this specimen is tested in compression. So it is tested in compression, means suppose this is the load, means stress is equal to P upon A. This will be the stress, and when theta is equal to 45 degree, is on this plane, there is a maximum shear stress, and this will be equal to half of this stress, means half of this is the shear stress, and this half of the shear stress, half of this normal stress will give the shear stress here, and this shear stress has been given as 25 Newton per mm square. So P will be 25 into 2A, means 50 into area of cross sections. This is equal to pi by 4 into 25 square. So I will get this P, I will get this one. This is 25,543 Newton, and this theta will be 45 degree to the plane axial compressions. So this is the right option. An element in plane stress is subjected to normal stresses. This is P2. Both stresses and shearing stress of this one. What is the normal stress? Pn acting on an element rotated through an angle of 45 degree. This 45 is compressive. It is like this. This is 120. and this is 45. And when it is rotated 45 means on this plane, when theta is 45 degree. So on this plane, my theta is 45 degree. This is the Mohr's origin. This is 120 and this is 45. Means total is 165. 165. So half of this, and shear stress is 30. It is 30 here and 30 here also. So this will be the center of the Mohr circle. So I want to know the normal stress. So when theta is 45 degree means 2 theta from here, it is 90 degree. So this will be the normal stress. This angle will be equal to 90 minus this angle will be equal to how much? This is 30. This is 165 means half of this will be 82.5. So this 30 upon 82.5 to 10 inverse will give this angle, and this angle will be equal to so this angle will be approximately 20 degree. So this will be 70 degrees approximately. So this is 70 and this normal stress is equal to this much. So obviously this is also equal to 82.5. This is 45 means this is 37.5. So this 37.5 plus this 37.5 is horizontal projection of this one, and this is the radius. Radius is equal to 82.5 square plus 30 square root. I will get radius. This radius is equal to this radius, and cos of this angle, cos of 70 degree, I will get this one. With this I will get my normal stress is this one. Both are modes. What is the normal stress is oh so some Oh. Some mistake is there. Hmm. Okay. Both are compressive, I think. Both are. I think. Some mistake is there. I think this is 45, 120. Normal stress means both are compressive. So it is 82.5 from here to here. This is the center. 82.5. This is 82.5 plus this one. So when the rotation is 3 Newton per mm square means rotation in this case is this mistake is there. This is means I think some mistake is there in the question. Theta is rotated through angle of 45 degrees. Whereas this theta is this is 45. This is 120. So simply we can also find it by putting in the formula. This is P1 plus P2 by 2 plus P1 minus P2 by 2 cos 2 theta plus Q into sin 2 theta. The nature of the stresses is same, so we can take any. So this is 120 plus 45 by 2 plus this minus 45 by 2 into cos 2 theta means cos 90 degree plus this is Q is equal to 30 into sin 90 degree. So this is 45 degree. So this way it will be equal to 0 and this is 30 and this will be 82.5 plus 30 is equal to 112.5 and this is compressive, so it will be minus. So this is the right options. Yes, in this case also we can, this is 30, this is 30. So My Mohr circle will be like this. When the angle is 45 degree means 2 theta is equal to 90 degree. So my 2 theta is 90 degree. It is 2 theta is equal to 90 degree. I think some mistake is there. This is perpendicular to this one. So this is 2 theta means this is 90 degree. The perpendicular of this is this one. This is 82.5 plus this will be half of this one into cos of this. It will be easy by directly calculating through this formula. So tensile stresses at a point across two mutually perpendicular planes are this. What are the tangential and normal stresses respectively on a plane inclined at 30 degree to the axis of the minor stress, like this. This is 150. This is 80. So what are tangential and normal stresses respectively on a plane inclined at 30 degree to the axis of the minor. This is the axis of the minor stress is this. So it is inclined with this. This is the 30 degree. So theta is 30 degree. So in this case, I have to find the tangential and normal stresses. So with this is 150, this is 80. So shear stress here are 0. This is my Mohr circle. This will be average of this will be 230 by 2 means 115 plus 60 degree. This angle is 60 degree and this is 70. Difference of this dash 75. This is 70 and half of this is 35. So this is also 35. So plus normal stress is equal to 115 plus this horizontal composition of this 35 cos 60. So 115 plus 35 into cos, and 866 means this will becomes equal to cos 60. This will become equal to 132.5. Oh, cos 60 means 1 by 2. Oh, yes. 1 by 2 means 17.5. So it will be worth 32.5. This is the normal stress, and this need not to be checked. Otherwise, you can check. This is equal to 35 into sin 60. Sin 60 means 35 into root 3 by 2, or 35 into 0.866. So this will be 30.31. So this is the right option. Which one of the following statements is not correct regarding principal stresses and plane? The planes on which shearing stresses are 0 are called principal planes. Means carefully you should read the question. I have to choose the option which is not correct. So most of the students make a mistake by not reading this one. So first of all, you should carefully read this one. So I have to take the option which is not correct. The plane on which shearing stresses are 0 are called principal planes, and the stress normal to the principal plane are called principal stress. This is okay. The principal planes are the planes of maximum or minimum normal stresses. This is also okay. The planes of extreme shear stresses are at 90 degree to the principal planes. This is wrong. This is not 90, this is 45 degree. The sum of the normal stresses any two mutual perpendicular directions is general constant in case of two dimensions. This is also okay. Means this one is the correct option. This is not correct. So I have to find this is the not correct option. So this one is the right answer. Given the state of stress sigma x is equal to sigma y is equal to this one. This is compressive, and this value is equal to this one. This is the point where this is greater than 0, and shear stress tau xy is equal to 0. Means this is the point. Which one of the following statement is not correct? The radius of the Mohr circle R is 0. Yes. So this radius is equal to 0. In this case, the formula for the radius is sigma x minus sigma y by 2 square plus tau xy. This is the, so in this case, sigma x is equal to sigma y, both are equal, means this is 0, and tau xy is also 0. It means radius is equal to 0. So this will behave as a point. My Mohr circle is just a point. So this is okay. So I have to find the not correct options. This is okay. No shear stress exists on any plane passing through this point. This is also okay. Any plane which is passing through this, shear stress will be equal to 0. This is also okay. The state of stress shown here is called a state of pure shear. This is not okay. The normal stress is same for R plane passing through this point. This is also okay. So not correct option is this one. So this is the right option. So now PYQ of the GATE. An element is subjected to biaxial normal tensile strain of this one. normal strain in the plane of maximum shear strain. Means if I draw a Mohr circle, then it will be, this is 0.0030, this is Ex, and this Ey is equal to 0.000. So if I draw a Mohr circle, this will be like this. I have to know the normal strain in the plane of maximum shear strain. So plane of maximum shear strain means my maximum shear strain is here. This one is the maximum shear strain, and this is equal to gamma xy by 2. Gamma max we can say. So this is equal to, this is the plane of maximum shear strain. So on this plane, my normal strain is equal to how much? This is equal to the average of this and this. So it will be 0.0025. So this is the right option. Now for a plane stress problem, the state of stress at a point P is represented by this one. By how much angle theta in degree the stress element should be rotated in order to get the plane of maximum shear stress. Now if this is theta, then this line is normal to this and this is normal to this. So this is also theta. It means my rotation is anti-clockwise. So theta is positive. So this theta is positive. So if I draw a Mohr circle, then it will be like this. This is 80, this is 20, and shear stress is 25. So this is negative. Negative means upward, and this is positive. So this is my Mohr circle. So this is the angle. So for maximum shear stress, how much rotation is there? My maximum shear stress is, this is the maximum shear stress, Q max. Then for this, the rotation is basically this plane is represented by this one. So this plane is represented by this one, and this is maximum shear stress plane. Means I have to know this angle. So this is 2 times of the theta. This is 2 theta, and this will be equal to, this 2 theta is equal to 90 minus this angle. This 2 theta is equal to 90 minus this angle. This angle is equal to, obviously, this is tan inverse, this is 25 divided by this one. This is 20, 80. So this is 100 means this is 50 and this is also 50. So 25 upon 50 means 1 by 2. So this 2 theta is equal to 90 minus tan inverse 1 by 2. This will be equal to tan inverse 1 by 2 This is 26.565. So theta will be equal to this minus 90 divided by 2. So with this I will get, this is 31.7 degree. So this is the right option. In a two-dimensional stress analysis, the state of stress at a point P is represented by this one. The necessary and sufficient conditions for existence of the state of pure shear. So in case of pure shear is, what is the case of pure shear? In case of pure shear, my sigma x and sigma yy should be equal to 0. Should be equal to 0. So this is a case of pure shear. This is tau xy. So in case of pure shear, my this sigma x-axis here is equal to 0. This sigma yy on this plane is also equal to 0. Means sigma x-axis plus sigma yy is equal to 0 plus 0 is equal to 0. Means this is the right option. The state of stress represented by the Mohr circle shown in the figure is, what is this? Hydrostatic stress, uniaxial tension, biaxial tension, or pure shear. This is a case of pure shear. For pure shear, suppose this is Q, this is, if I draw a Mohr circle for this, then it will be, this is the origin. So this normal stress is 0 and this is Q, means I will get this point, and on this plane this is clockwise, means negative, and in this plane also it is 0. So if I draw a circle, it will be like this. So this is a Mohr circle and this is the origin. So this Mohr circle is for case of pure shear. The state of stress in a deformable body is shown in the figure. Consider transformation of the stress from the xy coordinates. So this is x coordinate, this is y coordinates. So there is a transformation. Consider transformation of the stress from this xy coordinates to this one, small x, xy coordinates. The angle theta located the x-axis is assumed to be positive from the x-axis is counterclockwise. So this is counterclockwise, means rotation is positive, theta is positive. The absolute magnitude of the shear stress component sigma xy round to up to 1 decimal plane in the xy coordinate system will be equal to so this is a case, this is the normal stress 120, this is the normal stress. So P normal is equal to, formula is P1 plus P2 by 2 plus P1 minus P2 by 2 cos 2 theta plus Q sin 2 theta. This is the formula. So in this case the normal stress is 120. This is the normal stress 120 and P1 is equal to 40. This is P2 and P1 minus P2 by 2 into cos 2 theta. Since rotation is, you can also represent it like this. So this is a angle with this, means my rotation is like this. So theta is positive. So this theta is equal to, basically this is 30 degree, this is 90, means this is 60 degree. If this is 60 degree, means this angle is 60 degree. So this angle will also be equal to, this is normal to this, 60 degree. So this will be Q cos 2 theta, means cos 120 degree, plus Q. This shear stress is tau xy, and into sin 120. So with this, I can find the value of the tau xy. Everything is known. So tau xy with this formula will be 96.2 MPa. So I can find tau xy from this angle, from this equation. So it will be this one. Next is the infinitesimal element shown in the figure represent the state of stress at a point in a body. What is the magnitude of the maximum principal stress in integer at the point? So I can represent it like this. This is 6, this is 3. So if this is 6, then this is also equal to 6, and this will be 3. So this is the plane where this normal stress is 5, and this here, this is 4. So this is P normal, and this is PT. Suppose stress in this case it is P. This will obviously, if it is 3, then it will be 3. This is 3. So P normal is equal to 5. P normal is equal to P1 plus P2 by 2 plus P1 minus P2 by 2. He wants to know the maximum principal stress. So for maximum principal stress, formula is sigma is equal to P1 plus P2 by 2 plus P1 minus P2 by 2 square plus Q square. So P1 is equal to, P1 is unknown, and P2 is equal to 6 by 2 plus P1 minus 6 by 2 whole square plus Q is equal to 3. It means for finding this maximum principal stress, first I have to find the P1. P1 can be found from the equations. Since P normal means 5, this is equal to P1 plus P2 by 2 plus P1 minus P2 by 2 cos 90 2 theta plus Q is 3 sin 90, 2 theta. So with this cos 90 is equal to 0 and this is 1. So this P1 will be equal to 5 minus 3 means 2. 2 into 2 means 4. So P1 will be equal to 4 minus 6 means minus 2. So P1 is equal to minus 2. So after putting this P1 is equal to minus 2 here, I will get this will be minus 2 plus 6 by 2 plus minus 2 minus 6 by 2 whole square plus 3 square. So this will be equal to, this is 4 by 2 means 2. And this will be 8 by 2 means 8 by 2 means 4. 4 square means 16 plus 3 square. 16 plus 9, 25. So this will be 5. So 5 plus 2 is equal to 7. So the answer is 7 Newton per mm square. This is also a simple case. In a two-dimensional stress analysis, the state of stress at a point is shown in the figure. The values of the length of PQ. This PQ is 4. This is QR is 3. And this is 5 unit respectively. The principal stresses round off to one-dimensional plane will be equal to how much? Principal stresses, these are the principal stresses sigma x and sigma y, because no shear stress is acting on these planes, means these are the principal planes. So I have to find the value of the sigma x and sigma y. So if this theta is, if this is theta, then sin theta is equal to this 3 upon 5 and cos theta is equal to 4 upon 5. Now this is the normal stress 120. This normal stress is equal to how much? This is, if I put the formula, then it will be sigma x cos square theta plus sigma y sin square theta, means cos theta is equal to 4 by 5. So it will be sigma x 16 upon 25 plus sigma y into 9 upon 25, means 16 sigma x plus 9 sigma y is equal to 120 into 25. This is my equation number 1. Second equation, this shear stress. This shear stress 70 is equal to minus P1 minus P2 by 2 sin 2 theta. This is the formula. So minus P1 is equal to, this is sigma x minus sigma y by 2 into sin 2 theta, means 2 sin theta cos theta. So it will be minus sigma x 2 sin theta, means 2 into 3 by 5 into 4 by 5. So it will be 12 upon 25. So 12 upon 25 means it will be minus 12x plus 12 sigma y is equal to 70 into 25. So these are the two equations. From these two equations we can easily find the sigma x and the sigma y. So after getting the solution, what I will get? So sigma x will be 67.5 and this is 213.33 Newton per mm square. So we will get sigma x and sigma y. So means this one is the right option. The three-dimensional state of stress at the point is this one. This is, so here these are the, along the diagonal, these are the principal stresses. Means this is sigma 1 is equal to 10, sigma 2 is equal to 40, and sigma 3 is equal to 0. So these are the principal stresses, and shear stress is a 0. The maximum shear stress at the point is given by, so maximum stress formula is Qmax is equal to sigma 1 minus sigma 2 by 3. So if I do this minus this by 2 means 10 minus 40 by 2, or 40 minus 0 by 2, or 0 minus 10 by 2. So it will be 30 by 2 means minus 15, then it will be 20, it will be 5. Means 20 is the, out of this the maximum is 20. So maximum shear stress is 20. So this is the right option. Now find the correct match between the plane stress states and the Mohr circle. So obviously in case of pure shear, this is a case of pure shear. So for pure shear, this is the, so with Q it is 4, and for this is the uniaxial test. Uniaxial stress system is, this is the origin, this is 10, it is 0 here, so it will be, and P it will be 3. So Q4 and P 3. Q4 and P3 means this one is the right option, and it is not required to check the other two, because this condition is fulfilled only by this one. A plane strain problem in a xy plane must satisfy the conditions. So in case of plane strain, it is like this. My Ex will exist, Ey will also exist, and this gamma xy will all exist. But normal to this plane, my strain in the zy directions, in the, this is equal to 0. Also gamma xz or gamma yz is equal to 0. Means this is the conditions. So this is gamma xz, gamma zy. So this is the right option. And this is the end of the lectures. I hope you enjoyed my lectures. This is a very important lectures. So thank you very much for listening, and good night and good night. Thank you.